Welcome back to the workshop. We want to continue taking a look at section 1.4, algorithms and their efficiency. And we want to look at an algorithm that would help us out with finding the subsets of a set. So in the last section, we talked about the knapsack problem. And we said, all right, here's a collection of things that we can take backpacking. And let's evaluate each possible subset to see how helpful or useful it is, and if it weighs less than 30 pounds, which is fantastic, right? If we wanted to do that, that'd be fine. There were a lot of subsets that we said that there are. So maybe we wouldn't actually do it, but it's still an example of something that could be done when we're talking about computers. So we say to ourselves, how do we generate all of the subsets? How do I know when I've had them all? Well, of course, we can use our counting techniques to know how many subsets there are, but then we also want to say, all right, what are the subsets? And so that's what we want to do first. We want to first find a way to describe the subsets. And then once we can do that, we can use the next subset algorithm to find the next subset. So there's a place to start, of course, and then the next subset algorithm will give us the next one. So let's take a look at our notes. What we want to do is we want to think of, maybe we could think of back to when we were talking about the knapsack problem, and there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items that we could pack. And we said that we could either pack it or not pack it. So there were two options of what we could do. Now, instead of writing a 2 for how many options there are, what we could do is we could say, how many of these things are we packing? Okay, well, I'm either going to pack it, so there's 1 of them, or I'm not going to pack it, so there's 0 of them. So what we end up with is we end up with a list of, or a string of 0s and 1s that would give us what objects are included and what objects are not included in our subset. So we can use a string of 0s and 1s to describe our subset. Okay, so what we do is we call the string, or we give it a generic form and call it A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, and A12. So there are 12 A's here because we have 12 items. A sub 1 is going to be either 0 or 1 to indicate whether it's included, a 1, or not included, a 0. A2, same thing, all the way down to A12. So let's take a look at a basic example of this. All right, and let's consider just the set A, B, C. So what we've got is, now let's see how they've described it here, because they use some specific language. All right, so what we do is we say that x1 is object 1, x2 is object 2, x3 is object 3, and so on. So the A's represent the 0s and 1s, and the X's represent the objects. If A1 is 1, then x1 is included. If A3 is 1, then x3 is included. If A7 is 0, then x7 is not included. Okay, so if we have the set A, B, C, we have object 1 is A, object 2 is B, and object 3 is C. So we consider what A sub 1, A sub 2, and A sub 3 are to determine the inclusion or not inclusion of the object. Okay, so let's take a look at each of these strings of 0s and 1s and determine which of the letters A, B, and C are included in our subset. So the string 101 says include A, don't include B, include C. A1 is 1, so we include x1. A2 is 0, so we do not include x2, so we don't include B. A3 is 1, so we do include x3, which is C. For 0, 0, 1, A1 being 0 says don't include x1, so we do not include A. A2 being 0 says we do not include x2, so we do not include B. And A3 being 1 says we do include x sub 3, which is C. And then similarly, right, 1, 1, 1 says include all of them. And 1, 1, 0 says include only A and B. So for 3 objects, right, we said for a set with 3 objects, there would be 2 to the 3 subsets. So that's 8 subsets. These are 4 of them. So how could we generate them all? Well, we could generate them all relatively easily because there's only 8. If we were talking about 100 elements, then generating them all would be quite tedious because that would be 2 to the 100th power different subsets. So to help us out, we use the next subset algorithm. So if we have a string of 1s and 0s, this algorithm will give us the next subset. All right. So step 1 is initialization, and we set k equal to n. Okay, why do we do that? Well, we'll see in just a moment. Step 2 is we're going to look for the rightmost 0. So if I were to consider 1, 0, 1, 0, 1, 1, 1, if I'm looking for the rightmost 0, of course, visually, I can do that very quickly. Here is the rightmost 0. It's all the way right here. Well, this is A1, this is A2, A3, A4, A5, A6, and A7. So A1 is 1, A2 is 0, A3 is 1, A4 is 0, A5 is 1, A6 is 1, and A7 is 1. Okay, so I've just repeated these so they line up better. So I can see that this is my rightmost 0. As I move to the right, that's the last 0 that I approach. Or moving from the right, that's the first 0 that I hit. And that's what the algorithm does. So they start over here at A sub 7. So we set k equal to 7. And then while k is greater than 1, so while we haven't reached this one yet, and we have that the value is 1, so we start here and say, as long as it's 1, keep moving to the left, right? Replace k with k minus 1. This is 1, so take k and replace it with k minus 1. 7 minus 1 is 6. Is this 1? Yes. All right, subtract k and move, subtract 1 from k and move over here. Is a sub 5 1? Yes. Subtract 1 from k and check a sub 4. Is a sub 4 1? No, no, we no longer have that condition. That kicks us out of the loop and we move on to step 3. Excellent. Okay, so we move on to step 3. Once we get to step 3, then what we're going to do is we're now going to form the next string. So there's a couple of things that go on here. What we're going to do is we're going to change the rightmost 0 to a 1. So we're going to go ahead and in this step, the string becomes 1, 0, 1, 1, 1, 1, 1. Excellent. Once we've changed this guy to a 1, what we're going to do is we're going to change all of the remaining ones, or all of the following ones, to zeros. So we're going to change all of these to zeros. And that's what this loop does. This changes all of these to 0. So what we do is we take j from k plus 1 to n. So j is going to go from 4, not from 4, but from 5 to 6 to 7. So we would end up with, when j is equal to 5, we replace, sorry, this one was a 0. I didn't mean to change that. When j is equal to 5, right, k we said was 4, so j is equal to 5, we change that one, and then we run through the loop again. When j is equal to 6, then we run through the loop again. when j is equal to 7. So we have replaced everything to the right with zeros because those were all ones. When we look for the rightmost zero, everything that follows would be a 1. So once we change that 0 to a 1, we make everything that follows a 0. Once we've done that, this is the next subset. Okay, so the next subset algorithm, this looks a lot longer than our previous algorithms, but it's even simpler in terms of what it actually says to do. All that it says to do is to find the rightmost 0, change it to a 1, and then change everything that follows to 0. Done. You have found the next subset. All right. So if we wanted to do that, quickly, quick notice, if I started out, let's say I wanted 5 objects, 1, 2, 3, 4, 5. If I wanted to run through all of the subsets, actually, you know what? Let's do it with 3, 0, 0, 0. That's relatively quick. I could apply the next subset algorithm to this string of zeros. And this would be a great place to start because everything is 0. I include nothing, and then I'm going to build up to the entire set. So if I were to start with this string and apply the next subset algorithm, I would change the rightmost 0 to a 1, and then everything that follows becomes a 0. But nothing follows because 0 is all the way at the right. Okay, cool. Apply the next subset algorithm again. You change the rightmost 0 to a 1, and then change everything that follows to a 0. Now you look for the rightmost one, right? Apply the algorithm again, look for the next subset. If we apply the algorithm again, we find the rightmost 0, and we change it to a 1, and then change everything that follows to a 0. Well, there was nothing that followed, so we're all set. Now again, we find the rightmost 0, we change it to a 1, and we change everything that follows to a 0. We can apply the algorithm again. Here's the rightmost 0. So we change it to a 1 and change everything that follows to a 0. Apply the algorithm again. Here's the rightmost 0. Change it to a 1. Change everything that follows to a 0. Apply the algorithm again. Here's the rightmost 0. Change it to a 1. Nothing followed, so we're all set. Apply the algorithm again, and it's going to print out this string contains all 1s because we would have gone through these. Okay. If we were to put in a string of all 1s while k is greater than 1 and a sub k is equal to 1, we want to replace k with k minus 1. But all of them are equal to 1, so we subtract 1 n times n minus n, right? We would get to 0. So k is equal to 0 if it were all 1s. If k is greater than or equal to 1, well, it's not. K is equal to 0. So that brings us all the way down to the otherwise. So if this is true, k is greater than 1, we go ahead and change the rest to zeros. But k is not greater than 1 when it's all 1s. Okay, if k would be equal to 0. So then we say, oh, that's the end of the list. And that gives us our 1, 2, 3, 4, 5, 6, 7, 8 subsets of a set with 3 elements. Awesome. All right, so that's all that I want to share for now. We'll go ahead and take a look at a couple of really quick examples in our next video, and we'll be all set with this section. So I'll see you guys in just a moment.